Alright, so we're used to this kind of problem where an object is heated to 100 degrees, it's placed in a room that's 20 degrees, so we know the heat's going to dissipate and it's going to end up at a temperature of 20 degrees. But that's not so important here, except that when we're reading this question we can go, alright, that means at T equals 0, the temperature, which in this case is H, is 100 degrees, and we also know that after 10 minutes it tells us the temperature is 80, so that's handy to note that. Because it says solve the initial value problem, find the constant k. So here we've got dH to T is k lots of H minus 20. Alright, so if we want to find what H is equal to here, the temperature, the thing that's got H in it here is the H minus 20, so I'm actually going to divide by H minus 20 so that the H side can be with the DH and the K can stay over here with the dt. I'm going to times both sides by dt so that they kind of match up like that. And then of course this would just be, I'm integrating a log here, so I'm integrating, so that becomes log of H minus 20 on that side, and over here k, integrating k with respect to t would become kt, but of course we'll add a constant. So putting in, so using t equals 0 and h equals 100, we'll have log 80 here, 100 minus 20 is 80, and over here we will have 0 plus c, so log 80 is c. So if I put that back in, I've got log of, I know this is going to be positive, so I'll just keep it like this. Alright, we've got kt plus c, which is log 80. So using my log laws, I've got h minus 20, I'm going to minus log 8, so that's over 8, equals kt. And if I exponentialize both sides, I've got e to the kt here. So if I make h the subject, I've got, I've got h, that should be 80, shouldn't it? That's better. So here I'm going to have 80 lots of e to the kts, and I'm going to add 20, and I'm trying to find h, so now I've used this, so now I'm going to use this one. So when t equals 10, I know that h equals 80, so 80 equals 80 e to the 10k plus 20. So I've got 60 over 80, or 6 over 8, left on this side equals e to the 10k. So if I log both sides, here I've got log 3/4 on this side. Here I've got k 10k. That looks bad. So you can see my k value is going to be, let's go, 1/10 of log 3/4. So if I put that back in now, that information back in, I'll go up here. I've got h being equal to, so I found both my, all my unknowns, my c and now my k. So h is equal to 80 e to the kt plus 20, where k is 1/10 log 3/4. So rather than write it up here, I'll just say where k is equal to that. And I could factorize by 20 and get this value here. Alright, so that's kind of the first part. The second part says we are now, so I'm trying to remember that or write that down somewhere, because perhaps we will use that. So the second part says, now at the 10-minute mark, refrigeration equipment is turned on. So it lowers the temperature in the room by 1 degree per minute. And we're assuming the rate of change in temperature continues to be proportional to the difference, and the value of k is unchanged, so we know what k is. So now if we think about it at our new time 0, so we're starting, again at this 10-minute mark, say, then we've been told that we've already found that our temperature, we know it's been told to us before that at the 10-minute mark the temperature is 80 degrees. So now we're going to call that the 0-minute mark. And we've got to include now the fact that if I'm looking at the change in the temperature, it's now K, it's still got the H minus, it's the difference between the temperature in the room and the other temperature of the object, but now it's also the temperature in the room is lowering by 1 degree per minute. So I'm going to minus, so it was 20, but now this 20 is being lowered by 1 degree each minute. So if I minus T, that, you know, the first minute that's 1, the second minute that's 2. So that's what I'm comparing it to. So if I have a look at that, that's really just K H minus 20 plus T. All right, that's my dH dt. Write down the initial value problem in terms of K. So that would be the initial value problem, right? So if I gave you H dash equals this equation, and here is some initial values, can you find what H is equal to? The equation for H, which would be the solution. So this together, this equation and the stuff in the box is my initial value problem. So then if I let y equal to h minus 20 plus t, this would become ky. So now in terms of y, this is now my problem is my h dash equals ky, but in terms of all y's, so I want y dash, not h dash, in order to answer this question. So we've got, let me see, so yes, dH to t is ky, I'm going to use that, but I'm going to start with this here. So if I know y equals, so remember the IVP I need is the y dash, so if I just differentiate that, I'm going to get, so dy dt, I want dH to t, oops, that's an h, plus 1 with respect to t. And we know that this is, so dH to t, we've got up here, is k, I already know it's ky, so ky plus 1. So this y dash equals ky plus 1, along with, we had y of 0 being equal to 60. I feel like I wrote the wrong thing down before. Oh, so this is my y value. Yes, this is my y value. So at time, that's why I wrote it down, because at time 0, so this is our new time 0, then t would be 0. Remember our h was 80, so 80 take away 20 is now 60. So this is in terms of y. You have to keep thinking, what variables am I using here? What am I doing? So the IVP, the initial value problem, consists of both this equation in y dash with y's in it, and this initial value. So y of 0 is going to be 60. So when time equals 0, we've now got 60 for our y value. All right, so the next thing we want to do is find the y, the solution, and hence determine h of t. So go back to h of t, find y first. All right, so it kind of makes it difficult because it's a two-stepper. So if I look at this as dy dt equals ky plus 1, and I want to find y. So I'm going to all the y parts, but unfortunately it's not a multiplication, it's an addition here. So I'm going to have to, in order to put it on the other side, I'm going to have to divide by ky plus 1 with respect to y, and then I've got, on the other side, I have just 1 with respect to dt. Okay, but I'm going to run out of room, so right over here. So if I put 1 on k, I don't want that constant there out there, I'm going to get y plus, that's going to have to be a 1 on k with respect to y, equaling 1 dt. So why don't I put that k, I'll times by k there. There we go, get rid of that. So you can see on this side it's really nice. It'll just be k, we're integrating with respect to t, so kt plus c. And on this side I'm going to have log of y plus 1 on k. Alright, so in order to get rid of that log, I can exponentialize both sides. And you see when I do exponentialize, I'm going to get kt plus c up here. So it's an exponential, which is always positive. So I'll just go like this. And what I can also do at the same time is that breaks off, this breaks off e to the kt times e to the c. So if we make e to the c equal a, it will look like a e to the kt, and I'm going to subtract 1 on k. So a is equal to this e to the c part. Alright, so if that's the case, now let's go to our y value. Y is, so now we've got what y is, we need to find what a and k are, but let's have a look. We do know 0, and this was our initial value, so let's use that. So when y equals 60, we've got our t is 0 here, our t is 0. So we've got a e to the 0 is 1, minus 1 on k. So we can, sorry, running out of room, make that a equals 60 plus 1 on k. And if I pop that back into this y equation, if I put that back in there, what I really have is y equals 60 plus 1 on k. That's a e to the kt minus 1 on k. In terms of remembering that h, where am I? Remembering that, I'll write it here, y is equal to h minus 20 plus t from here. So remembering that, we can write y is, because we want it in terms of h, not y's, so now we've got to change it back. So y is h minus 20 plus t, equals 60 plus 1 on k, e to the kt minus 1 on k. Alright, so we've got h equals 60 plus 1 on k, e to the kt minus 1 on k. We're going to add 20 and subtract t. And that's our h of t. That's what we're looking for. So we found y. Here's where we found y. Alright, yes, it's in terms of k and t, but remember that's going to be our problem. Okay, now we're back. We've got our initial here, but that was in terms of y, and we wanted to hence determine in terms of h. So we had to remember that we need to, once we kind of find our solve for y, we've got to put that back in terms of h. Hope that helped.